So the lesson objective is I can solve more challenging logarithmic equations. Just to review the steps to solve logarithms. So again, condense the logarithms on each side, rewrite the equation in exponential form, and then solve and check for extraneous solutions. Here we have log base 2 of 3x minus 4 equals 7. So everything's condensed, so we can rewrite this in exponential form. This is going to be 2 to the 7th power equals 3x minus 4. So we'll have 3x minus 4 equals 120, or rather 120 equals 3x minus 4. We now can add 4 to both sides. Then we'll have 132 equals 3x. We can divide both sides by 3. And we'll get that x equals 44. We can go ahead and plug in 44. We get log base 2 of 3 times 44 minus 4, which is log base 2 of 128. So we need to think of what number to the 2 to what power equals 128, and that's going to be 7. So we did this right. Here we have ln of 2a equals 9. So this is technically log base e of 2a equals 9. So the way to rewrite this is e to the 9th equals 2a. And then you can divide both sides by 2. And you'll get that a is e to the 9th divided by 2, which is about 4,051.54. And I would do this as ln 2 of 4051.5419637877. This is what the answer is on the calculator, and that should give you 9. Here we have log base 6 of w plus 7 minus 5 equals negative 3. So in a problem like this, what you really do is keep this as like x. So do x minus 5 equals negative 3. How do you solve for x? You add 5 to both sides. You get x equals 2. And then we just rewrite this with what it really is. Log base 6 of w plus 7 equals 2, which means 6w plus 7 equals 6 to the 2nd power. So w plus 7 equals 36. So w is going to equal 29. And we can check that. Log base 6 of 29 plus 7. We want to see if that equals 2. That's log base 6 of 36. 6 to what power is going to be 36, and that's 2. So that's right. Here we have 2 log base 9 of k squared plus 2k plus 4 equals 5. So again, you want to solve it almost like it's this. 2x plus 4 equals 5. Log of everything is just like its own variable. You minus 4 from both sides. You get 2x equals 1. You get x equals 1/2. So it's log base 9 of k squared plus 2k is 1/2. So it's going to be k squared plus 2k is 9 to the 1/2 power. 9 to the 1/2 is the square root of 9, which is just 3. So it's k squared plus 2k equals 3. So then we'll have k squared plus 2k minus 3 equals 0. And then we think of two numbers that multiply to negative 3 and add to positive 2. That's going to be positive 3 and negative 1. So our options are k plus 3 equals 0 or k minus 1 equals 0. So k is either 1 or k is negative 3. So I can go ahead and plug 1 into this expression here. So we get log base 9 of 1 plus 2. So it's going to be log base 9 of 3. 9 to what power is going to be 3, and that's 1/2. Then we can do log base 9 of negative 3 squared plus 2 times negative 3. That's going to be log base 9 of 9 minus 6, which is log base 9 of 3, which is again 1/2. So both the solutions work. Here we have log base 4 of 2v plus 3 plus log base 4 of 2v minus 3 equals 2. So we can go ahead and first condense this to one log expression. So we get log base 4 of 2v plus 3 times 2v minus 3 equals 2. So we can rewrite this as the 2v plus 3 times 2v minus 3 equals 4 to the second power. So that's going to be 4v squared minus 9 equals 16. We're going to add 9 to both sides. We'll get 4v squared equals 25. Divide both sides by 4. Then v squared equals 25 over 4. So v equals square root of 5 over 2. Or v equals negative square root of 5 over 2. Not really sure where I came up with the square root of 5. It's just 5 halves or negative 5 halves. All right, so we can check this. So when we plug in the negative 5 halves, what we end up getting is log base 4 of negative 2, and then we get log base 4 of negative 8, and those are extraneous solutions. So in this case, v cannot equal negative 5 halves. V can equal 5 halves, though, because if we made each of these positive, then we would be able to take the log of what's inside the parentheses. We can't do log base 4 of a negative and log base 4 of a negative. That's what our problem is. Here we have 1/3 times ln of 27 plus ln of x minus 5 equals 4. So we're first going to bring this in, and we'll have ln of 27 to the 1/3 plus ln of x minus 5. 27 to the 1/3 is really the cube root of 27, so we need to think of a number we can multiply by itself 3 times to get 27, and that's going to be 3. So we can rewrite this equation as ln of 3 plus ln of x minus 5 equals 4. So we can combine these to have ln of 3 times x minus 5 equals 4. So we can combine inside the parentheses. We'll have ln of 3x minus 15 equals 4. And then to cancel ln, we take e to both sides. So we have 3x minus 15 equals e to the 4th. We can add 15 to both sides. So we'll have 3x equal. If you put e to the 4th plus 15 in your calculator, you'll get 69.5982. Then you'll get for an answer that x is about 23.2. Here we have log base 2 of n minus 3 plus log base 2 of n plus 1 equals 5. So we first are going to combine the logarithms on the left side. So we'll have log base 2 of n minus 3 times n plus 1 equals 5. So then we'll have log base 2 of n squared minus 2n minus 3 equals 5. So then we'll have n squared minus 2n minus 3 equals 2 to the 5th. 2 to the 5th is going to be the same as 32. So we can rewrite this as n squared minus 2n minus 3 equals 32, which is then n squared minus 2n minus 35, which is 0. And now we need to think of two numbers that multiply to negative 35 and that add to negative 2. So that's going to be positive 7 and negative 5. Oh, wait, I'm sorry. Negative 7 and positive 5. So then this will be n either 7 or n is negative 5. And then to check this, we have to use our original expression. So if we plug in negative 5, we have log base 2 of negative 5 minus 3 plus log base 2 of negative 5 plus 1, which is log base 2 of negative 8 plus log base 4 of negative 4. So this is a problem. We cannot have negatives, so we cannot have an answer of negative 5. Now, if we try 7, we have log base 2 of 7 minus 3 plus log base 2 of 7 plus 1, which is log base 2 of 4 plus log base 2 of 8, which is log base 2 of 32, which ends up being just 5. After this lesson, you should be able to solve more challenging logarithmic equations.